Well, hello. My name is Satria. I will be presenting an ongoing research project that we have here at the VA Hospital Center for Limb Loss and Mobility in Seattle. So before I begin, there are four terms that I'd like to introduce to you. So the first one is the maximum power output on the joint in our body over our body mass, which what we call the joint power. And then for the next term, this is the transfer of our body weight from one leg to the other leg during walking. And this one and the joint power that you just saw are typically symmetrical between left and right among individuals without limb amputation or leg amputation. And then the next one is the force from the ground that is equal in magnitude, but opposite in direction to our body weight during walking. And again, this is typically symmetrical between left side and right side among individuals without leg amputation. And then the last one is the amputation that is below the knee or between the knee joint and the ankle joint. And the right picture shows you the below knee artificial limb, or what we call the below knee prosthesis. It is common for people with below knee amputation to walk asymmetrically and even without carrying weight. And this is primarily because of the limb loss, leading to secondary problems of like injuries and difficulty in walking. And so with weight added, this is our question. We're really interested to find out if carrying such loads or carrying such weights actually affect their walking asymmetry, and if so, by how much and how bad it is affected. And so the first aim of our study is to investigate the effect of carrying weight on one side, on the hip power, on both their prosthetic side, as well as their intact side during walking, especially during their self-selected walking speed. And then our next aim is to assess the between leg weight transfer strategy during walking while carrying side load. And again, this is also done when they're walking at their self-selected walking speed. And so to answer this specific question of interest, we are recruiting 10 adults with below knee amputation who have used a prosthesis in performing their activities of daily living. For example, wearing a prosthesis for at least like 4 hours per day. And to run this experiment, we will have three conditions. So the first one is with no weight added condition. The second one is prosthetic side weight carry condition. And the last one is the intact side weight carry condition. So each participant will be wearing a standard of care prosthetic foot, which is non-articulated, or simply it's no hinge. But this is what we call the energy storage and return prosthetic foot. And then each of the participants will also carry a padded baby carrier. And this is to add the weight itself, which is about 30 pounds, or which is equal to 13.6 kilograms. And note that the participants will wear this on the prosthetic side and on the intact side. And then the participants will complete 2 visits. The first visit is the acclimation period, whereas the second visit is the experiment period itself, which is done in the laboratory, just like the picture that you see on the screen. And then the data that we collect from the experiment will then be processed to a custom data processing software to calculate variables of interest, for example, to calculate the hip joint power. And then for the weight transfer, we are interested to measure the loading and unloading rates. And these are just basically the slopes of the maximum ground force from the ground over the instantaneous time during walking. And then we are further interested to compare these loading and unloading rates of this population to the loading and unloading rates of individuals without leg amputation. And these are typically, again, almost symmetrical between left and right. And so we anticipate that this study may not be that generalizable to other prosthesis users who carry different types of loads. This study may only also be applicable to a conventional prosthetic feet, just like one that we use in experiments. And we expect to be able to answer if carrying a side load will exacerbate this secondary problem. And then we also hope to provide guidance for weight transfer strategy for the rehabilitation for individuals with below knee amputation. And so this is the end of my talk. Thank you very much for your attention and thank you for attending. And I welcome any questions that you may have at the end. Thank you.